All right, so in this video, I'm going to solve these quadratic trig equations, and I'm going to solve them all between 0 and 2 pi. Now, I believe all of these questions can be done without a calculator, but you can also use a calculator as well. If you're not using a calculator, you're going to end up using special triangles. I'm just going to use a calculator, but either way, we're going to get the same solution. Let's take a look at this first example over here. In this first example, we can clearly see that we have a common factor of 2 sine x. So I'm going to factor out 2 sine x. I'm left with sec x minus root 3. That equals to 0. Now that it's factored, I can flip this. This is just going to be 2 sine x equals to 0, which means that if I divide by 2, sine x equals to 0. And this is going to be sec x equals to positive root 3 if you make it equal to 0 and solve it, which means that the reciprocal of sec is cos. So cos x equals 1 over root 3. Now I have to solve these two linear trig equations for my x. Over here, I'm going to use my graph because if you have 0, 1, or negative 1, you want to use your graphs to solve it. I know that this is 2 pi and this is pi 0, 1, negative 1. I know that sine x is 0 at 3 different points in between 0 and 2 pi. So I have 3 solutions here, which is 0, pi, and 2 pi. And over here, I'm going to solve this using my cast rule. This is where you can use special triangles as well. So I know cos is positive in these two quadrants over here. And I need to find my acute angle. So you can use special triangles if you don't want to use your calculator, but I'm going to do the cos inverse of 1 over root 3 in my calculator. And I get a decimal. So I guess you cannot use special triangles here. And I guess it makes sense because 1 over root 3 does not exist in any of the special triangles. So we just get 0.955 as the two acute angles. So my two solutions here are x equals to 0.955. That's my first solution in the first quadrant there. And my second solution, which is starting here and going all the way around till here, a full circle is 2 pi. I'm going to subtract 0.955 and do that on my calculator. I will get 5.328 as my solution. So it looks like we do need a calculator for this one. Let's go to the second question over here. Now, this question is actually a really, really difficult one. Probably the hardest quadratic trig, or one of the hardest that I've seen, because I can't factor anything here. And there's not really anything simple I can do. So what I'm going to do is I'm going to convert this sec square x into tan square x plus 1. And that is using my trig identity, my Pythagorean trig identity. Okay, now that I've done that, I'm going to convert this quote into a tan. So I have 2 over tan x plus tan square x plus 1 equals to 0. Then I'm just going to multiply everything by tan x. So basically, I'll have 2 over tan x plus tan cube x over tan x plus tan x over tan x equals 0. The other side is 0. 0 times tan x is that. And now I can cancel off all my denominators because they'll just all multiply with 0 on the other side and the denominator will disappear. I'm just left with 2 plus tan cube x plus tan x equals to 0. This is a cubic equation. I'm going to write it in order. So tan cube x plus tan x plus 2 equals to 0. Then to make things easy, I'm just going to say let a equal to tan x. So I have a cubed plus a plus 2 equals to 0. I need to factor this with synthetic division. Pretty easy to tell that -1 is your solution for factor theorem here, because -1 cubed is -1 plus -1 is -2, -2 plus 2 is 0. So I know that my first and easiest factor to use is -1 over here. My coefficients for the cube is 1, for the square is 0, a term is 1, for the 2 is 2. If you don't understand what's going on here, you need to go back and learn synthetic division and factor theorem. I'm not going to explain it in this video. Bring the 1 down. -1 times 1 is -1. 0 plus -1. -1 times -1. 1 plus 1 is 2. -1 times 2 is -2. And then I do get a remainder of 0. Means my answer is definitely correct so far. So now I can rewrite this in factored form. This -1 gives me an a plus 1. And then this is a quadratic equation with the coefficients. So a squared minus a plus 2 equals to 0. And what multiplies to 2 and adds to a -1? Nothing. So this has no solution. And this has a solution of a equals -1. I'm going to replace my a back with tan x because that's what I subbed in a for earlier. So tan x equals to -1. We're going to use cast rule here. For tan, the only exception is 0 where you use a graph. Everything else you use cast rule. So tan is positive in these two quadrants, which means tan is negative in these two quadrants. To find the acute angle, I'll do the tan inverse of +1, which is just pi over 4. You can use special triangles over here as well. And then my two solutions, my first solution is pi minus pi over 4, which is 3 pi over 4. My second solution is 2 pi minus pi over 4, which is 7 pi over 4. So only two solutions in this question. Definitely a really tough one. And let's go to the third question next. This one looks a bit easier. This last one is again going to be a tough one. So if you enjoyed that second one there, I really like that one. If you enjoyed it, I would suggest definitely waiting till the last one. That's going to be a fun one as well. Maybe not as difficult as the second one though. Let's start with this one. The first thing I'm going to do is I'm going to move this to this side over here and make it equal to 0. And then it's pretty easy to common factor out the cotex. I'm left with cosec square x minus 2 equals to 0. This one's also going to be a slightly tricky one. We'll explain why, but it's a really good one to definitely understand as well, especially if you have a hard math course. Oh, I'm not going to be able to fit both of these probably in the same page. Let's try. Cosec square x. This one's a pretty difficult one. Equals to 2. Okay, so there's multiple reasons why this is difficult. First of all, this is a squared equation. Second of all, if we have cot x equals to 0 here, let's just tackle this one first. If I have cot x equals to 0, I can switch cot to tan. The tan x will become 1 over 0, which is infinity. So basically, I mean, you can just technically write it as infinity here. It's actually not true, but this is just the vertical asymptotes. So again, we're going to draw a tan graph. I'm going to draw it between 0 and 2 pi. Because when you get 0 or infinity for tan, you basically have to use a tan graph. So this is 2 pi over here. And where are the two vertical asymptotes between 0 and 2 pi? Well, this is in the middle, which is pi, which means this is pi over 2. And this is 3 pi over 2. So my first two solutions in this question are pi over 2 and 3 pi over 2. When I come to this question over here, I'm not even going to do this one on this page. I'm going to first rewrite this as sine square x equals to 1 over 2. I just converted cosec to sine and flip this upside down. Now when I square root both sides, I'm going to split into two equations over here. The first equation is going to be positive, so sine x equals to positive root 1 over 2, and over here sine x equals to negative root 1 over 2. And if you don't have a calculator, you can simplify this to 1 over root 2, and this one is negative 1 over root 2, so then you can use special triangles as well if you want. Now we're going to solve these using our cast rule. Cast rule for each one. So we know sine is positive in these two quadrants, which means sine is negative in these two quadrants. The acute angle is going to be identical in all of these because it's the same number, just the sign is different. So sine inverse of 1 over root 2 is just pi over 4. All our acute angles are pi over 4. And then we have our four solutions. So here my first solution is pi over 4. Second solution is pi minus pi over 4, which is 3 pi over 4. Third solution is pi plus pi over 4, which is 5 pi over 4. And last solution is 2 pi minus pi over 4, which is 7 pi over 4. So in this question, that we have 1, 2, 3, 4, 5, 6 solutions in total. Technically, I don't know if this equation is quadratic or actually considered cubic, but it's something weird. Definitely a lot of solutions. And let's get into the last question now. I'll do this one. See if I can squeeze it in here. I think it should squeeze in half a page. So it was 3 tan cube x minus tan x. 3 tan cube x minus tan x equals 0. This might actually be easier than the last one we did, just because that one was much harder than I actually initially thought it was. So this one, pretty simple. First step is common factor of tan x. Left with 3 tan squared x minus 1 equals to 0. So here my solution is tan x equals to 0. And should probably write that neater. Over here, my solution is tan square x equals to positive 1 over 3. Let me just solve this one first really quick. Remember, tan x equals to 0. You want to use your tan graph. So that's my tan graph between 0 and 2 pi, and that's pi. And then I have 3 points where tan x is equal to 0, 0 pi, and 2 pi. So I have 3 solutions here. Basically, tan x equals to 0 is the same as sine x equals to 0. Then here I have tan x equals to 1 over 3. So when I square root, I'm going to continue over here. I'm going to have two things. Tan x equals to 1 over root 3. I basically square rooted the top and the bottom, but I just did a bit quicker this time compared to the last problem. And here I'll have tan x equals negative 1 over root 3. I believe this one can be done with special triangles. Again, I'm going to use a calculator. So let's do the cast rule to begin with. Honestly, though, this doesn't matter. We know it's in the end, it's going to be all 4 quadrants over both the ones. But let's just do it anyways, just to be accurate. So tan is positive in these 2 quadrants, and tan is negative in these 2 quadrants. To find the acute angle, I'll do the tan inverse of 1 over root 3, and I get pi over 6. So yes, like I mentioned, this one actually can be done with special triangles. You don't need a calculator. Then over here, my first solution is pi over 6. My second solution is pi plus pi over 6, which is 7 pi over 6. Over here, my first solution is pi minus pi over 6, which is 5 pi over 6. And the last solution is 2 pi minus pi over 6, which is 11 pi over 6. So in this question, as you can see, we have 1, 2, 3, 4, 5, 6, 7 solutions. Again, I don't know if this is quadratic, but actually this one's definitely cubic, but I think the last two that we did are definitely cubic equations, because it doesn't make sense for them to be called quadratic.